Okay. Let's start this again. Okay. And Mike, it's your responsibility. Give me a thumbs up if you see it. Okay.
Okay,
Here.
okay. Put me on the spot,
The
sure.
University of Idaho McCall Outdoor Science School is located on the College of Natural Resources McCall Field campus, bordering the state's premier wilderness area. Its programs present place-based and STEM learning opportunities to communities throughout Idaho.
What Moss does better than anybody else is making that connection. Why is science important? You're sitting in a classroom, you've been learning math for 5 years, and then you go to Moss and you get involved in a scientific problem where you're having to use those skills and you can see the impact.
Moss's place-based, web-based, and extension outreach programs allow them to share, teach, and work with K-12 students and teachers everywhere, forming a critical link to Idaho STEM education opportunities. Graduate students from the College of Natural Resources teach thousands of students each year, all while continuing their own education. This creates a dynamic and mutually beneficial partnership between the K-12 community and the University of Idaho.
Okay, did everybody hear this video now? Or yeah, so basically the why I like this video, I think it gives a nice context for you to understand of where our students are coming from. So again, we have a residential graduate program where a lot of our graduates or where our graduate students are taking graduate level classes, but then at the same time, they're also involved in some active teaching. And that teaching always happens in the outdoors. So the unique challenge for these students was to use the STELLA to teach about remote sensing in the outdoors. And so with that little introduction, I would like to introduce our two graduate students. They graduated actually a few weeks ago, just a few weeks ago. I would like to introduce them to you. Tyler Bland, who is on Zoom here. She's already back home. Will be presenting to us today, as well as John Patrick, who's right here with me. And again, these students are not necessarily remote sensing experts, but these students are, like they're science educators and communicators that try to integrate the STELLA device in some of their teaching. And so basically with that little introduction, they will be presenting some of their field experiences with the STELLA instrument, and hopefully will give you an idea of some of their experiences with the device, but also hopefully at the end we'll spark some conversation about further uses of these devices and how we can kind of use them to teach about remote sensing. So with that introduction, I suggest that we start with John, since he's next to me, and we can start with that. So yeah, John, if you want to take it away, and I'm sorry, it's really like Mike, you did such an amazing job inviting people because it's just constantly beep blinking on my end here. So let people into the, oh yeah, view. Okay, great. So yeah, so John, take it away and tell us about your experience with the STELLA.
Awesome. Yeah, thanks, John. Hey, everybody. Like Jan said, my name is John. I'm a recent graduate of Moss. Before I came to Moss, I actually did have the privilege of working at Johnson Space Center in the Office of STEM Engagement as an education coordinator there for a few years after I finished teaching high school. So it was really cool to get to reconnect with NASA STEM and get to use the STELLA tool. So the main crux of my lesson that I taught was about the carbon cycle and gross primary productivity, and using remote sensing to teach students about just kind of how much carbon is either being sequestered or cycling through our ecosystem. And so yeah, let's dive into it. There we go. Okay. Just for a little background and setting. So the setting for this lesson was Ponderosa State Park. You guys saw a little bit of that in the video. Here's a nice little shot of some of the beautiful scenery we have out here. I was primarily using the namesake trees of our park, the Ponderosa pine. And so we used the Stellas to measure different samples of Ponderosa pine from with different levels of biomass. I'll talk a little bit about that more in the lesson implementation. But the main thing that we were doing with the Stellas was we were calculating this NIRV spectral index, which is the near infrared reflectance of vegetation. And so this was an index that was described in this paper here, Badgley et al., about canopy near infrared reflectance. And the paper got into discussing trying to measure gross primary productivity. That is a very important thing to measure as far as like understanding how carbon cycling in our atmosphere. But one of the things that can be difficult about remote sensing is that you have this issue of like not everything that you're taking a picture of is the thing you want to study. So you have land, you have trees that you might be looking at, but you also have things water, urban development, soil. And so this paper described this strategy for calculating this index called NIRV. And which is they found to be very highly correlated with gross primary productivity. So I wanted to use this index in our lesson, and I'll show you a little bit more about how that's calculated when we talk about the lesson implementation. So as far as the connections to the Landsat lesson, like Jan said, I'm certainly no remote sensing expert myself, so this was a very new thing for me to dive into, and I learned a lot about this process or about remote sensing science and doing this, which was really exciting. But also it was very, very new for a lot of the students. The students that I taught were 5th and 6th graders primarily. And so they were generally pretty familiar with things like, ultraviolet radiation or visible light, but they may have not really considered infrared or near infrared radiation before or have even heard of it. Some of the students that, maybe had experience in the outdoors with hunting, kind of knew about like night vision or thermal imaging. But I wanted to make some clear connections to them about like the bigger picture of how this type of these different wavelengths of light are studied. So part of the lesson opened up with students reading some handouts from NASA's Tour the Electromagnetic Spectrum resource. We passed these out. I use these three because these are the three that the STELLA 1.1 measured. So we passed these out to different like little groups within our field group. Students would read these and kind of report out on what they learned about visible light and what we can study with visible light. So in addition to studying the trees in the park themselves, I wanted to make some connections to like, here's the broader picture of what scientists are studying by looking at visible infrared and near infrared radiation. So this resource was really helpful. Thank you, Mike, of course, for sending it to me. It was a really, really well done piece of science communication here. So the students enjoyed diving into this, and they were able to make some connections about some things that they already knew, and then also build on that a little bit more. So for the lesson implementation, it was about a 3-hour lesson or so all told for using the STELLA 1.1. We started this picture here in the bottom left with myself standing around the tree. We did a tree ID exercise. This is something we do every week with our students. And so I kind of incorporated that into the opening of this lesson. It was really helpful for the students to understand the different tree species in the park. And so I think here we're standing in front of either a spruce or a Douglas fir tree, but ultimately we were looking at needles from ponderosa pine. So we started out with a tree ID. That way the students could get familiar with their setting, with the setting and the different, we like to say the neighbors around the park. We had a couple different iterations of the lesson. At the top here, this was an early attempt at using this idea Jan talked about, Jan and I talked about, like kind of creating landscape boards where I had drilled some holes into these pieces of plywood, and we put little samples of different trees into them. I thought it was a good idea, but I think in practice it probably added a few too many confounding factors, just because the geometry of all the needles was different. They were sticking out in different directions, and it was hard to sort of get that very uniform. So we ended up settling on, and here's a picture of Tyler. I hope you don't mind I used a picture of you in my presentation, but here is Tyler using the Stellas with these black foam sit pads. And so we have these sit pads that we take out into the park just for kids to sit on the ground, for insulation and to stay dry. And they're pretty flat as far as like just the color. It's very uniform. And it was easy for us to get the needle samples, in a uniform orientation. So what we ended up doing was we used these sit pads to sample when we actually took the sample. And here you can see Tyler is using one of the 3D printed stands we found on the Stella website. And this was a nice tool that helped us standardize the distance that the Stellas were recording the samples from. So what we did was we went out into the park, we reviewed the spectral handout so the students could familiarize themselves with the different parts of the electromagnetic spectrum that the Stella was measuring. We collected the needles. You can see here in this earlier iteration of the lesson, we were looking at these are some Doug fir needles, these are some ponderosa needles. But in working on it and talking with Jan and building this lesson out, we came to the idea that it would be better to just, at least for my lesson, we just sampled ponderosa needles of different biomasses so that we could compare the amount of carbon sequestered and the spectral index, the nerve between 25, 50, and 100 needle samples. So I had typically about 8 to 9 students in the field group, and we split them up into 3 different groups to collect, the different levels of needle samples, and then we measured the reflectance of those 3 samples. So what we did was we would set the needles out on the foam sit pads here. And one of the things I was talking with the students about was making sure that we were orienting it right so that we had the sun coming this way and then the Stella reading the needles. Students, weren't thinking about standing in front of it and casting their shadows. So we had to have some discussions about making sure that we were measuring from the right side so that we weren't casting a shadow and potentially altering the results. Also, we talked about the geometry of the needle samples on the board or on the sit pad. The first time we did it, the students understandably just kind of took the needles and tossed them down on the sit pad. So we got to talk a little bit about lining them all up so that we had a more uniform sample. And so we were able to kind of work in some of the technical aspects of sampling with a remote sensing tool as well. We took an iPad out into the field with us. One of the difficult things about this piece of technology in the field was that the data is stored on the SD card, and so we don't have access to laptops typically, or screens or anything like that. So we had an iPad where Tyler and I were able to download Microsoft Excel on there, and we use an SD card reader into the iPad to take the information we needed off the Stella. And so that was a nice mobile solution for how to get that data in the field. And we went back to our wall tent. We have a series of wall tents here on campus that are sort of like our classrooms. And I think this was actually a kind of a cold day too. So that was a good incentive for the students to say, let's get this data collected and then we can go back to the wall tent where the wood stove is and actually do our calculations. And so basically what I did was I took the information from the Stella on the iPad, I posted it up here on the board for the students to work with. And they had this data table in their field notebooks that where they were able to record some information like the number of needles they sampled, the range that they sampled it from, the surface temperature. We didn't use this for this lesson necessarily, but I wanted it was a piece of information that the Stella was displaying, so I left a place for them to record that here. And then the 2 wavelengths that we were interested in using was the red at 650 nanometers and then the near infrared at 860. And so once I recorded that information off the Stella and put it on the board, students would write that down here and then complete their calculations. So there were two spectral indices they were calculating. The first was NDVI, which is the normalized difference vegetative index. Did I get that right? Okay, vegetation index. And this was one that the Bagley et al. Paper had talked about. It's used very often in like studying vegetation with remote sensing, and you have to figure that in order to calculate the nerve. So what students did was they calculated their NDVI with this equation here, and then they plugged this information into the nerve equation, which is NDVI times the near infrared reflectance. And so then they were able to get a value for nerve, and they had 3 different values to compare based on the biomass samples. The sort of elaborate part of our lesson, if you're thinking about like a 5E structure, this was sort of our explain, and then they got into the elaborate, where now we're trying to connect these values here, the nerve, to carbon dioxide. And so we have a lot of these Vernier CO2 sensors. If you're not familiar with these, they're a great little tool. This thing plugs into a little handheld computer, and you have these sample chambers where you put your sample, in this case the needles, and it can tell you your CO2 in parts per million. This was where the biggest difficulty came in for my lesson. I tried calibrating these things a couple times, and they just weren't working the way I wanted to. I got CO2 measurements that were kind of all over the place. Some were reading like super low, and some were reading like, in the 10,000s. And so that was the part that didn't quite go the way I wanted it to. But ideally what the students would do with this lesson is, now once they have their nerve and the CO2, they can create a scatter plot comparing how that spectral index relates to the amount of photosynthesis that's going on in the needle sample. So I think like for future iterations of this lesson, probably just need like a little bit more robust calibration of these sensors, or I'm not sure, maybe we have some faulty instruments here, but the numbers they were giving me were kind of all over the place, difficult to deal with for the students to make sense of. However, I think overall there was still a lot of really good that came out of this lesson. So this was the idea here again, though, is just to see if we could relate like this idea of gross primary productivity in 2 different types of measurements. So measuring CO2 and then using this spectral index that the research showed was highly correlated to that. So I did do a pre and post survey with my students as part of, we had a couple research questions we were asking, and you can see them here in the table. So I wanted to know a few things about students, their attitudes towards studying climate science, what's their role, and like how the remote sensing is used to study the Earth. So I think, one of the things that STELLA is really fantastic at is it's a model of sort of a pretty abstract concept for some students. They can't see the Landsat satellites. It's hard for them to kind of envision that sometimes because it's so far away. It's not something they can hold in their hand. So I was interested in understanding like how this lesson changed their opinion or their understanding of how remote sensing work is done. And so here a few results from our survey, or from this survey. So on this Likert scale question here, 1 to 10, how interested are you? I did see some significant growth in the average score, which I thought was really encouraging. Students, were generally fairly interested. I think students these days are like very acutely aware of the importance of climate education and just like how much it matters to them. So I did see like a pretty high interest already going in, but in analyzing this data, we did see a significant increase in the student interest in this type of education. And I had, my sample size here was about 17 students. So this was over the course of 2 weeks that I taught this lesson. A couple students in in this question here about studying trees, they said things like, and looking back at my survey results or my responses today, students were saying things like, why is it important to study trees? Because we want to know if the air is fresh. And so they had the like very generic, understanding of the importance of trees. And then 3 students specifically they talked about and the post survey, these questions, if I wasn't clear about that, were asked before and after the lesson. And so I had 3 students that showed like really specific understanding in it's important to study trees because we need to understand how much carbon dioxide they are taking out of the atmosphere. And so that was really encouraging to me that this lesson was a way to, you know, really dig into the carbon cycle. And again, these are 5th and 6th grade students. So, you know, that is not something that I think they had really studied a lot in their science classes, maybe at like a very, you know, 10,000 foot view as far as like, you know, trees do photosynthesis, but they were showing some specific improvement in their understanding of the carbon cycle, which was great. And then I also had 6 students in my post survey that mentioned that like specifically mentioned that they really enjoyed using the STELLA. That's on this last question here. How is it similar or different? Several of these students like specifically mentioned using the STELLA, using the technology was very fun and engaging, which was really awesome because, you know, one of the things in terms of like, or in addition to the content we teach, like one of the goals here at Moss is really just to have like students develop a positive attitude, positive relationship towards science, and come away just because we only have our students for a week, right? So we want them to come to Moss and to leave here thinking, wow, it was really fun to do science. It was really fun to do science outside specifically. And I think the STELLA really supported those goals because I had a good chunk of students that were really enjoyed using the technology. They just thought it was super cool. And then they also mentioned that it was very different from anything they do in their regular science class, which again is like, it helps meet our goals of like, you know, these kids coming away from Moss with a memorable experience that's going to stick with them for a long time. And so just to discuss a few of the results here and you know, my takeaways from this lesson. There was a study by Hagelin et al. About you know, using infrared. Sorry, I'm making sure I have I'm getting the pictures right. Using infrared cameras and how it was a very engaging technique for inviting inquiry. And so I think that my work with the STELLA supports that research that like these types of tools are very useful for engaging students with concepts related to climate education. In the post-lesson or survey, there were some students here on the second point that said they felt like their role was to like tell other kids in their school about this. They felt that maybe like they were in, you know, sort of, they had this cool opportunity and what they needed to do was share it. And so this supports some of the research here from this Kumar et al. Paper about like there is some positive like social learning impacts that can come from using tools like this. So it was really, it's hard for me to know how that's going to go because I don't get to follow up with these students necessarily. But I was interested to see that a few students said that like, I want to share with my classmates about this. I want to tell other people about, you know, about climate change or climate or using the STELLA. And so I thought that this was definitely worth noting that, you know, these kind of tools can drive conversations among students or you know, improve like the social learning that goes on as well, because that is a very important aspect to talking about climate education. Students need to not only talk with their teachers about it, but also with each other. This is more, you know, my personal belief as a teacher who's experienced with using the next generation science standards. Modeling is a huge aspect of those standards, and like getting students to understand and work with models is really important and a big part of NGSS. And so I really love the STELLA as that in that way. Like it is taking something way up in orbit and bringing it right down into the hands of students. And I think that's like a really powerful tool. So it's remote sensing work like we've learned so much from it, and there's so many powerful things you can teach students about the ways we've used remote sensing to understand our climate, our ecosystems, the way that we're changing the planet. And so I think personally, I think the STELLA is a really cool tool to use to take that concept and like bring it right down to earth, literally. I guess pun intended there. And then so as far as suggestions for improving the STELLA, I think I'm missing a one here. But the STELLA 1.1, so in an outdoor setting, like I think getting the data was probably the most difficult part for us. I would love to see, and you know, this is something for like the STELLA team to think about. Like, I would love to see a screen display that can read out what the SD card has in the field. Not sure if that's possible or not, but I think that would have been probably the biggest thing that would have helped us implementing this in an outdoor classroom. It's totally doable if you have, like, the iPad worked for us, but again, not everyone has access to that technology. Or, you know, in a setting like where we are at Moss, of course, we didn't have access to like projectors and computers and stuff like that. So I think that would have been a nice suggestion from my experience. Other than that, I think the STELLA was really engaging, easy for me to use. Once I got the hang of it, and the students also really enjoyed it. Even just something as simple as like 1, 2, 3 button, right? Like they just really lived for that moment. And so I was really thrilled to get to use it. Yeah, and that is all I have. If there's any, Jan, do we want to do questions individually, or?
You know, I think it would be good to move on to Tyler, and then we should have some time for some questions and answers. So yeah, thanks, John, for presenting that. And let's move to Tyler. I have to find her in this long list to give her access.
Maybe if I talk, it will push me to the top.
Okay, that's right. I just did that, Tyler. And so I'll make you a co-host.
Okay.
So you'll be able to share your screen.
Great.
And I stop sharing mine here.
All right. Should I be good to share, Jan?
You should be good to share. Yep.
Okay. Let's see here. Can everybody see my screen here?
It's put it in, so we see your PowerPoint slide. So
Okay, and then
put it in presenting mode now.
Yeah, here. All right. And like Jan said, my name is Tyler. I'm also a grad student from Moss. I graduated a few weeks ago. And I think me and John had similar lesson plans. So apologies for anything that's a bit redundant. But there are some slight differences. So yeah, using the STELLAs, again, at the McCall Outdoor Science School. So we have students for 1 week with us, and I focused on using the STELLAs 1 day out of those 3 days that I had them. And so we didn't have too much time, probably about like 4 to 5 hours, I would say we were focusing on this lesson using the STELLAs. Hold on here. Sweet. So why I was interested in incorporating STELLAs into my lesson planning at Moss, I was interested in looking at some photosynthetic phenology research. So using remote sensing satellites such as Landsat to kind of take a look at how the greenness or some of these spectral indices changes over time, and how that might correlate to carbon uptake potential in plants, and trying to figure out a way to kind of relate these big ideas from up and coming research to students who I was teaching to 8th grade students. And so the big idea that I wanted to share to students was that photosynthetic phenology can offer insights into the carbon cycle. So once again, that's just like changes in, I was looking specifically at ponderosa pine needles, similar to John. So how those might change, the greenness of those might change, and how that might tell us a little bit about something about the carbon uptake potential. Like more specifically, the goals I had is for scientific literacy, so they can develop an understanding of phenology and its relationship to photosynthesis, respiration, and carbon storage, and then just gaining familiarity in general with scientific tools. And it's really cool that we get to have a satellite handheld little mini satellite for students to use instead of having an abstract concept of a satellite that they're not able to like touch and see. And then the carbon sensors I also used. I think another one of the big goals I have is to develop science identity. So just making students feel confident in their ability to conduct scientific inquiry and yeah, feel good about their results and communicating those results to other people. So how I use the STELLA in this way is I kind of frame my lessons in what we call the learning cycle. So invitation, exploration, concept invention, and then we have this application portion. And that's where I think the STELLAs fit really nicely into my lesson plan. So applying some of the concepts we had talked about earlier in the lesson, like photosynthesis, respiration, and also just color and how spectral indices can be used to measure color. And using the STELLAs as an application or kind of like a guided inquiry to answer the question of like, how does greenness impact the carbon uptake potential? And so using the papers that I referenced earlier, there's a few ways that you can measure like greenness. John mentioned using these spectral indices, the NERV. I used with my students the green chromatic coordinate or GCC. And the GCC uses spectral bands only from the visible light spectrum, which I was drawn to that spectral index because of that. And I think it's easier for students who are younger age, who maybe haven't had a lot of background into the light spectrum. It was a approachable spectral index for those students to use because I think visible light is sometimes easier to grasp without a background in the light spectrum in general. So GCC is calculated, so we use the blue spectral bands, green and red. And that calculation is just the total of blue, green, and red. So you take the green and you divide that by green, blue, and red total. So it's simple calculation for students. It's not super complex. And so they gather their data in this data table here using the different levels of biomass, so similar to John. So you can see in this student's data table, they have the number of needles they had in each sample in the bottom left-hand corner of that chart. And then the batch number on the STELLA associated with that biomass. So 10 needles, 50 needles, 1 needle, and 20 needles. And so just altered biomass. And the more biomass you have, the higher that GCC value or that spectral index should be. So the more green it is. And then after they use the STELLAs you can see here in this photo, the student here on the right is taking a measurement with the STELLA using 1 needle. And you can kind of see in the corner here to the left, a sample of the larger biomass of needles. Here's just some more pictures of students using the STELLAs. We tried to use the stands. I don't know if we had like a user error of like when we were printing them or what went wrong with the stands, but they didn't quite align perfectly. So we were using them backwards here, but I think they still really helped to keep a consistent range above the needles so that they could get accurate measurements with the STELLAs. We were using the STELLAs on like the green mode or the average mode. So the STELLA would take 20 measurements of the needles and then average those together. And then we could get the data on the iPad. So in the picture here to the right, you can see me with the iPad trying to just tell the students so they can record the data averages of the red, blue, and green indices that they had collected. So kind of similarly to John, it was a little bit tricky to get in the field when we're outside, get the data that they had collected in the field without like a laptop. And a lot of these students also don't have experience with Excel at the grade that they're in now. So definitely just like, depending on what age group you're working with the STELLAs with, it's just altering the amount of facilitation, I guess, you have and getting that data from the STELLA onto their worksheet. After they had calculated those green chromatic coordinates from the STELLA data, we put the needles in carbon like flux chambers here, and they measured the amount of carbon dioxide before and after to try and find a change, and then graphed those changes. So if we had an increase in carbon dioxide in the chamber, then they know that that would be associated with respiration in the plant. And then if there was a decrease of carbon dioxide in that chamber, then that would be associated with photosynthesis. And I think this was a really important thing for students to see, is that trees don't only do photosynthesis. I think it's a really common misconception amongst especially middle school students. So I think it's cool for them to see the nuances of the carbon cycle and how these things are constantly moving and changing, and how that might relate to studying carbon in the future, and just like making meaning out of what they're doing. So what went well? I would say it was really awesome for students to have that hands-on experience with remote sensing, instead of just thinking of it as an abstract concept. Before I knew about the STELLAs, my original idea was to print out like images from a satellite and then just write at the bottom the different spectral band indices that the satellite collected that I would have just gotten ahead of time. But I don't think that would have had students nearly as engaged to just like give them the data. I think it's really important that they have the experience to go out into the field, see what they're measuring, and do it physically themselves. I think that's a really powerful experience that connects them with what they're doing in a way that like wouldn't have been possible without the STELLAs. I think that also really played a role in developing science identity for students and making them feel like they're doing real science instead of just being given a data table. Being a part of the data collection is, I think, a really important part of increasing their confidence with looking at data like this. Also, this is like an aside, but the STELLAs have a really good battery life. I feel like every week in the field, I struggle with a lot of my materials dying, the batteries go dead, and that wasn't something I struggled with the STELLAs at all. They functioned exactly how they were supposed to, and I could use them for like multiple hours or even days on end without having to charge them, which is a huge deal when you're out in the field all day with students. And the last thing you want is when your tools and the batteries go out. So that was like a random aside, but something I really appreciated about the STELLAs. I would say like what I could improve. I think, yeah, like kind of John had mentioned, the readability of the screen. So having to take out that micro SD card, put it in the reader and read from the iPad was just like cumbersome if you're working in the field. Obviously, if you had access to a lab or a computer, I don't think this would be as big of an issue, but I think if it's somehow possible to get like real-time data and averages on that screen, I think it could make the STELLA usable as like beyond an application tool, but like an exploration tool. So they could go around and kind of just use it as an extension of their senses to explore a little bit better with that like real-time feedback. I think it could be really useful for that. And the stand, again, I would love to hear from maybe some folks on the STELLA team who could maybe help me with this. And it could have been user error with the stands, but just trying to figure out a way to have the STELLA like on a solid surface so that students aren't having to hold it super still. I struggled with the STELLAs kind of falling off the stand when students weren't holding it nicely in place. So I think what would have helped me is like maybe like a video of someone using this. I know it's new, but I think that could have helped with my like success of using the stands and the STELLAs like in the most effective way. And then something I wish I would have had time for, like I said, I only had these students for a few days, but if you have a classroom or like students that you have those students for a year or a semester, I think using the STELLAs to observe like phenological changes is like a really cool opportunity because you could use the STELLA like every month and just observe how the color might change in the trees at your school over the course of a year and how that might change. So extending the time period that you're working with the STELLAs, I think would just really expand the opportunities for looking at like photosynthetic phenology. And also, I think that would help students gain familiarity with the STELLA and get more comfortable like using it, taking the data onto the Excel sheet and doing things like that. So I think there's a lot of potential for teachers who have students like over longer periods to utilize the STELLAs in like a longer term project or lab. Yeah, I would have loved to do that. I think that would be really cool direction to take the STELLAs. But the big takeaways are that it was really great for developing science identity in middle school students. One of their favorite things was carrying around the briefcase that says NASA on it. I know that's like a small thing, but it makes them feel like real scientists and that they're doing real science that matters. And I think they will remember that and take it back home with them. Yeah, like I said, ongoing projects or labs, I think would be better suited for using the STELLAs to look at photosynthetic phenology specifically, just so you could observe those changes over longer periods of time. And I do think STELLAs are like really well designed as they are to be used by students who have access to like a computer or have experience in Excel. So a way to like understand the data that they're seeing and work with it in a way that's more comfortable than it was for, I think, younger middle school age students. Like I can see this working really well in high school or like university level students, how they work now. And there's a super novel hands-on way to learn about remote sensing. Yeah, I think this is a really unique tool and it really just makes remote sensing, it brings it down the scale of what is accessible for a lot of people to understand. And I think that can create a lot of opportunities for just like wanting to learn more and just being more curious about how remote sensing can be used as a tool or way to better understand the world around us and answer more questions. But that's kind of all I had. So here's my contact information. Feel free to reach out if you have any questions or like need any of the materials that I talked about today. But that's kind of all I had for you guys.
Great, thanks, Tyler. So yeah, now we still have around 10 minutes or so, and I think that would be a good time for some questions, answers, conversation. So we can do this using the chat function, or we can also just do that. People like just unmuting themselves and asking a question.
I got one thing real quick. Just a note, and I gotta make sure that everyone knows this. The STELLA is not a proven science tool yet. So one of the big things, and one of the things, and I also want to say thank you all so much for putting this together. This is absolutely amazing. You all have done amazing work, and honestly, I'm just beaming over here. It's beautiful. One of the things that I did want to mention is that we need to basically enforce the idea of the field calibration. When you're out in the field, it needs to be against a calibrated surface, and then you take your measurements and all that, and some of the protocols in there. So we're still writing that up, but using like different materials for that. So right now we're looking at polystyrene foam as the prime example, as opposed to Spectralon, because not everyone can afford Spectralons. It's just way too expensive. But polystyrene seems to get us there. We also have like a cutting board, and then if it goes down to it, possibly just a few sheets of like white paper. So we're trying to have that sort of hierarchy, but getting that understanding of why we calibrate and all that sort of stuff. But again, I just want to say I'm over the moon with all of this, and honestly, I could keep going on. I have a bunch of really cool stuff that you all have mentioned that I have great knowledge of, that we're working with on the STELLA 1.2 and all that sort of stuff, but I don't want to overtake the questions. But I did want to thank you all again so much for all of this.
Well, Mike, and because I think this is a good point to say that, I think it's important to, we've seen there's certainly from a very strictly scientific perspective, there are still quite a few challenges, and it's often the difficulty, right? When you're an expert in an area, you have to let go of certain things and still keep it. And so, and that has been a challenge, but it's an interesting challenge. And we're kind of excited to continue working on some of these challenges, knowing that there are certainly things that were certainly imperfect. So,
well, I mean,
it's the first try.
Yeah, no, and again, it's fantastic, and you know, you like I said, I think you're getting really great results with all that. But I just wanted to at least have that in the back of your mind, at the very least. So
Okay.
there were a few questions in here.
Oh, in the chat. Okay.
Yeah,
Open it up.
let's see. I think Denise started off with asking if there's any graphing for students to complete.
Yeah, I can share. I don't know where would be a good place for me to send. I have like the slides and also like the student worksheets that I used for students in the field. If folks are interested in that, I can put it somewhere wherever that would be useful for folks.
Yeah, Mike, I was gonna suggest maybe, could we send you, and I mean, I know I was planning to send a lesson plan anyways, but I mean, feel free to share that with anyone in the group, anyone in this presentation. So I can certainly send you the lesson plan I wrote out that has the sheet with the calculations, because I saw that was another question too. And then Mike, you feel free to share that with anyone who's interested.
Yeah, absolutely. Like I said, this is really, really great. So yeah, I'll share it with everyone. So and the recording as well. And let's see here. Yeah, so Craig Kahn, I think I'm saying his last name correctly. I mess it up every now. To calculate NDVI, did you use, was it microwatts per centimeter squared data from 1.1? Did you use particular band for IRR? 610, 680, 730, or did you calculate an average for all the IRR values?
We used one specific band in the near infrared, which was the 860.
Okay.
So the equation that I had for NDVI was it was like a ratio of I can't remember off the top of my head, but I believe it's near minus the red 650 and then over the near plus the red. I can't remember where the plus or minus was on the top.
You said it right.
Okay, I got it right. Okay. Yeah, but we used the 8 because the Stella did had the near and 810 and 860, so we went with 860 and then used the red band in the 650 nanometers.
Awesome, thank you. And then how long do ponderosa pine needles continue to do photosynthesis and or respiration after being removed from the trees? This is from Justine Henning.
I don't know the exact answer to that. I mean, I know in the course of an afternoon, right, you can certainly still have like, because our lessons took place over the course of a couple hours.
Yeah.
Yeah, and I don't know if you know the upper limit of that, but within an afternoon, you can still get some photosynthesis taking place.
Yeah. Yeah, and that's a really good question. And again, it gets into those some of those questions where it can get really sciencey really quickly. But my experiences with these needles, like if you clip these needles, they still photosynthesize for a few hours. So it works pretty well. Obviously, it depends a little bit also, you know, what species you're working with onto. But my experience is it still works for a few hours that they photosynthesize. However, I also say what's very, very important is, right, and Tyler pointed this out, what makes this a little bit complicated too, that trees even, you know, they might also, especially when you pick leaves or needles in the afternoon, they respire too, right? Even though the sun is out, it's nice and warm, but they start respiring. And that's really confusing to students, that they think they should photosynthesize, but they don't. And so you have to be kind of ready for these questions. If you really want to see drawdown in CO2, it's your likelihood that you see a drawdown in CO2, so photosynthesis happening, is more in the morning, I would say. That's my experience. And so you will have these challenges where you you have to address, and Tyler and John certainly ran into some of these issues with when they taught this.
Cool.
Like the nuances with that was actually really interesting to my students, and they have a day where they can plan their own inquiry question to discover, and they use the Stellas to see if that green chromatic coordinate would change with sagebrush, so a totally different species, in the shade versus the sun. So they were trying to like kind of get into how these different factors were going to impact whether or not a leaf was photosynthesizing or respiring. So I think instead of looking at like as a solve, like we have to figure out a way to like make sure we're only getting samples that are photosynthesizing. I think it's was actually really beneficial for them to see both. And they were really curious about that and trying to narrow down like, oh, if we picked this one in the morning or in the sun or whatever the case is, like, how is that going to change what's happening?
Yeah, that's awesome. And also, you, Tyler, you had mentioned talking about, seeing like seasonal gradients and all that. And it's funny that you mentioned that. That was something that we were thinking about with this, especially like, even just daily gradients, because of course, the overpasses we're getting it at ideal times, generally speaking, for like, ideal greenness and all that. So seeing those gradients and those changes throughout the day and throughout the seasons, over time would be fantastic. And so that was, again, one of the ideas that we had. Also wanted to mention on the back of on the back of this guy here, you have a universal mount, so you can use this on a tripod. So you can have like a little tripod and just and screw it in there and have it steady. And you can set that, of course, at your different heights and all that. So I have some small tripods and stuff like that. A lot of your, input on, the improvements of Stellas and all that. I should note that a lot of that will be addressed with the 1.2 when it comes out, hopefully in the next few months. GPS, Wi-Fi, I just got confirmation that the Wi-Fi is now working on there. This is the base unit. I don't want to give a whole presentation on it, but or take up all of your time, but a lot of your concerns and thoughts and all that are fantastic. It's got magnetic couplers on here. This has the 18 band spectrometer from 410 to 940 nanometers with a surface temperature, LiDAR, a UV and a lux, as well as, of course, a place for a cuvette so you can do liquid spectroscopy. And it slides right on here like this. And we also have an air quality one that does that will be doing methane, particulates, and CO2 that you can slide on as well. And then 2.5 and all that. So lots of fun stuff coming up. But I just wanted to let you know that we hear your concerns and we're we're on it. And we and again, if you have any other awesome things, I mean, because again, it was just such a fantastic presentation. I really couldn't be happier. And I don't mean to overtake everything, so let me stop steamrolling everyone. So.
I just see this question, like Justin is asking student, but I'm wondering why you see more photosynthesis in the morning. It's really, it probably depends on where you're located, right? So we are located, and then really also the season too, right? In the spring, you might actually still see photosynthesis until 2, 3, 4 o'clock in the afternoon. But in July or so, or August, when it gets really hot here, these trees tend to shut down actually, around 11 or noon or so. At least that's what I have been seeing. And so it really depends on, again, on the season, and where you're located. So I would not say that that's generally true. So you will have to play around with that a little bit of when you see, when is your highest likelihood to see photosynthesis. But again, you will most likely will see changes in terms of time of year, when that's the best time to see photosynthesis.
Can I jump in? It would be so cool to get kids in different parts of the country to do this and then compare their results and communicate with each other. Like I'm in Maine and, I'm not using Stella at this point, but I'm watching my solar system and seeing when the sun is strongest and stuff, and it's not that hot here. So probably plants are working a little differently. It'd be so interesting for students here to use it and then to communicate with students, I don't know, in Texas or something.
Yeah, I like that. I like that. I think that would be a terrific idea, and I saw that there are some people from Globe on the call, and I wonder if there's an opportunity to do some of that and that data exchange.
I'm also just I have to go because I have a student, but I just want to mention for you folks in Idaho that on Math for Science, which is my nonprofit, in STEM education. We have a profile of a water resource engineer who is based in Idaho. She works for the state. And so if any of you in the future, if you're developing STELLA related lessons or non-STELLA lessons that involve measuring water, and you want me to connect you with this person, this water resource engineer, who again is in Idaho and works with the Snake River and stuff, you could reach out to me, justine@mathforscience.org. I'll put it in the chat.
Great, thanks.
Thanks, Justine.
Okay, we almost, well, we're a little bit over. Any last minute questions, folks? Okay, well, with that, Mike, thanks for organizing this. There were way more people than we anticipated. In fact, like we realized, you know, this was not quite polished or anything. It was just like we just wanted to share our first experiences with the instrument. Thanks to Tyler and thanks to John for, you know, sharing that and doing that. As we know, you know, doing things like that for the first time, there are so many challenges, and they did an amazing job, you know, doing this and trying to implement it. But there's still a lot more work that has to be done. But hopefully in the next, you know, we can do some of these things. And especially with a big community like that. So thanks everybody for listening to us, and thanks Tyler and John for sharing. Yeah, appreciate it.
Yeah, that was fantastic. Great. It was so great. I really appreciate it. That was just amazing, Tyler and John. I mean, just, yeah, over the moon happy. So thank you very much. That was amazing. And thank you, Jan.
It was a pleasure. We appreciate it, Mike. It was fun to get to work with the tools. I mean, it was cool just to, yeah, like Tyler said, just seeing the kids' face light up when they had the NASA briefcase was worth it. Just, yeah, it was a lot of fun. We enjoyed getting to learn